Now we're going to take a look at the laws of indices that pertain towards algebraic division. For example, look at the first law we have here, which says 1 over x to the n can be written as x to the minus n. So for example, 1 over 2 to the 2 can be written as 2 to the minus 2. 1 over 3 to the 5 can be written as 3 to the minus 5. So all you do is clearly what it says. Really easy law. The next one says x to the n over x to the m is equal to x to the n minus m. So, for example, 2 to the 3 over 2 to the 4 is equal to 2 to the 3 minus 4, which is 2 to the minus 1. Another example, 6 to the 5 divided by 6 to the 1 is equal to 6 to the power of 5 minus 1, which is 6 to the 4. So note, the bases of these two terms have to be the same for this rule to apply. So it has to be x to the n divided by x to the m. So for example, if I said 6 to the 4 divided by 5 to the 3, it isn't equal to 6 to the 4 minus who knows.
This law doesn't apply to this situation because for this situation, the base of the numerator and the denominator term must be the same. Here, the base of this term
is 6. The base of this term is 5. They're very different. But if we had 6 to the 4 divided by 6 to the 2, it would apply because we have x, which is 6, x 6, n 4, m 2. So we would have 6 to the 4 minus 2, which is 6 to the 2. The next law is as follows. Variable x divided by the variable y, all raised to the power of n, is equal to x to the n divided by y to the n. For example, 6 over 3 all raised to the power of 2 is equal to 6 to the 2
divided by 3 squared. I'll show you another example.
8 divided by 5 to the power of 3 is the same thing as 8 to the power of 3 divided by 5 to the power of 3. So that's this law. And finally, x over y to the power of minus n is the same thing as y over x to the power of n. And it can be said the other way around. Y over x to the power of n is equal to x over y to the power of minus n. So if you have a fraction raised to a certain power, if you want to take the reciprocal of the fraction,
because the reciprocal of y over x is x over y, you have to
negate the power. So for example, 2 divided by 3 raised to the power of minus 4 is the same thing as 3. If you take the reciprocal of the fraction, 3 divided by 2, negating the power, so multiplying that power by a minus 1 or by a minus sign gives 4. Another example, 1 over 2 to the power of 3, the same thing as 2 over 1 to the power of minus 3. So when you have a fraction raised to a certain power, you can take the reciprocal and raise it to a negative power and you haven't changed anything. So 1 over 2 to the power of 3 is equal to 2 over 1. So you just take the reciprocal, 2 over 1 to the power of negative 3. 6 over 4 to the power of minus 4 is the same thing as 4 over 6 to the power of 4. Because I just multiplied the power by a minus 1 or minus sign whenever I take the reciprocal of the fraction that is raised to a certain power. So this law is also easy. The key thing here is that you need to memorize all these laws of indices. These 4 especially apply to division. So I'll just place them neatly for your convenience. So here are the laws again. So 1 over x to the n is equal to x to the minus n. For example, 1 over 3 to the 2 is the same thing as 3 to the power of minus 2. X to the n over x to the m. Notice that the numerator and denominator have the same base. Is equal to x to the n minus m. So let me just put a bracket here. For example, 7 to the 2 divided by 7 to the power of 1 is equal to 7 to the power of 2 minus 1, which is 7 to the power of 1. X over y, all raised to the power of n, is equal to x to the n or y to the n. X is a variable, y is a variable, n is any number. So for example, when we now actually assign numbers to these variables and to n as well, we get, for example, 2 over 3 to the power of 7 is the same thing as 2 to the power of 7 divided by 3 to the power of 7, according to this rule. And finally, x over y raised to the power of minus n is equal to y over x raised to the power of n. The fraction here is a reciprocal of this fraction, and vice versa, but the powers have opposite signs. So for example, 10 over 3 to the power of minus 4 is the same thing as 3 over 10 to the power of 4. Take the reciprocal, multiply the power by a minus sign. Here's another example. 6 over 7 to the power of 8 is equal to 7 over 6. So I take the reciprocal of the fraction and then I negate the power, so minus 8. So 6 over 7 to the power of 8 is equal to 7 over 6 to the power of minus 8. So here's another example. We need to simplify x squared divided by x using any of the laws we've just learned. X squared divided by x is the same thing as x squared divided by x, or x squared over x. And if you recall from the laws of indices, x to the m divided by x to the n is equal to x to the m minus n. So I'm going to apply this to x squared over x. So doing that gives x squared over x to the power of 1, okay, is equal to x to the 2 minus 1. Just using that law. In this case, m is 2 and n is 1. So that's what we have here, x to the m, in our case it's 2, and minus n, in our case, n is 1. That's what we have here. So we have x to the 2 minus 1, which is 1. 2 minus 1 is 1, which gives x, and that's it. Here's another example, and it said simplify the expression below. Here we have x to the 5 divided by xy, which can be written as x to the power of 5 divided by xy, which is the same as x to the power of 5. Well, actually, let's use one of the rules we learned earlier. I can break this down into two fractions. If I write x to the 5 as x to the 5 times 1, I can break this expression down to the product of two fractions. In fact, let's even express it this way. So x to the 5 times 1 is the same thing as x to the 5. xy is the same thing as x times y. I can break this down into two fractions. The product of two fractions, actually. This has been treated in a previous video. So now I have x to the 5 over x times 1 over y. Why did I decide to have a fraction with just x's? Well, because it makes my life easier. I could have chosen x to the 5 and y and form a fraction that way. But I decided to form a fraction with x to the 5 and x because I can now simplify this expression using the rule x to the m over x to the n is equal to x to the m minus n. So this term becomes x to the 5 minus 1. And this is still times 1 over y. X to the 5 minus 1 is x to the 4 times 1 over y. And x to the 4 is the same thing as x to the 4 over 1 because a is the same thing as a over 1. Dividing a variable by 1 doesn't change the variable. So multiplying this out, we get x to the 4 times 1, which is x to the 4, 1 times y, which is y. And that's the simplified version of the original expression. If you don't understand what happened here, go back to the videos and check out the rules we considered governing the multiplication of fractions. Here's another example, and we're required to simplify this expression. We have one term as a fraction. I'm going to rewrite the second term as a fraction as follows. So we have x minus 3 divided by x plus 2. This is one fraction. This is the numerator, and this is the denominator. Times x plus 2 as a fraction is x plus 2 over 1. I'm going to go further to write this as x minus 3 times x plus 2 divided by x plus 2 times 1, which is x plus 2. So I'm just multiplying out these fractions. So this is what we have. Now, I can actually write this as x plus 2 times 1. And I can form a fraction with x plus 2 in the numerator and x plus 2 in the denominator. And I'm intentionally forming this fraction with like terms. And also, well, this gives a fraction x plus 2 over x plus 2 times the other fraction, which is formed by picking this numerator and 1, which is a denominator term, and this gives x minus 3 divided by 1. Now, x plus 2 divided by x plus 2 is equal to x plus 2 to the power of 1 minus 1. And this is times x minus 3 over 1. And this gives x plus 2 to the power of 0 times x minus 3 over 1, which is equal to 1. X plus 2 to the power of 0 is 1 times x minus 3 over 1, which is x minus 3. So this gives x minus 3. Now, how was this achieved? Well, if you recall, x to the m over x to the n is equal to x to the m minus n. In this case, our x is actually x plus 2. So we have x plus 2 to the m. Our m in this case is 1. Imagine we had a 1 here. Because x plus 2 to the 1 is the same thing as x plus 2. Any number raised to the 1 is itself. If you recall, a to the 1 is a, x to the 1 is x, and so on. So this is essentially x plus 2 to the power of 1 over x plus 2 to the power of 1, which is x plus 2 to the power of 1 minus 1, which is x plus 2 to the power of 0, which is what we have here. And remember, any variable raised to the power of 0, any number raised to the power of 0 is 1. And that's what was done here. And that's all. Here's a final example. Simplify the expression below. X squared times y plus 5 divided by x. This expression can be written as x squared times y plus 5 divided by x times 1. And now we can group fractions. I can form a fraction with these two, and I can form a fraction with these two. And I intentionally formed a fraction with the term involving x in the numerator and the term involving x in the denominator because, as you'll see shortly, I get this expression, x squared over x times y plus 5 over 1. And if you recall, we have a law of indices, or a law which says that a variable raised to the power of x to the m divided by x to the n is x to the m minus n. So this allows us to this law allows us to simplify expressions of this form, like this: x to the 2 divided by x, which you can say is x to the 1, is x to the 2 minus 1 times y plus 5 divided by 1. X to the 2 minus 1 is the same thing as x to the 1 times y plus 5 over 1, which is the same thing as y plus 5, or bracketed of course. X to the 1 is x times y plus 5. This simply is x into y plus 5. It's as simple as that. And we invoke this law. So far, we've had a look at the laws of indices. We've had a look at algebraic multiplication, algebraic division, and some rules that govern these processes. And we've gone through a few examples.